Um, okay, can you all hear me clear?
Yes, can hear.
Okay, thank you. We will begin this workshop now. Uh, we will begin the workshop now. So today I'll be talking about what is this again? Today I'll be discussing about how to use your neural network or implement your neural network in Matlab. So we are from this workshop is from MLDA, and we are a student-centric lab which aims to provide a platform to empower our EEE and IEM students in deploying machine learning and data analytics skills and knowledge in both academic and industrial settings. As a student committee, our mission is to execute and plan those events and workshops, and we do it through help with our state-of-the-art faculty, resource, and technical support facilities. We have a few things that we do here, which are machine learning projects. We also have industrial projects, career events and workshops, and even competitions. And most machine learning projects here are student lead. Industry projects are, we partner with industry, and we also even have career events that can help you find jobs and internships. So if you want to learn more about MLTA, please do visit our social media at LinkedIn or Instagram, or check out our YouTube for a lot of videos that can help you study neural network. Okay. So we are going to start today's workshop with introduction of the flow of the workshop. So first of all, I'm going to introduce you to Matlab. So this workshop will be very beginner friendly. In fact, I'll make it so that you can start without knowing even Matlab, And by the end of this workshop, you'll be able to deploy your CNN in the Matlab. And then I'll introduce you a bit about neural networks. So I'll not explain many mathematical formulas or how propagation works and all the sorts, but I'll only explain how you implement the basics of it and how you implement it in Matlab with a demo. And then I will let you hands-on practice. This hands-on practice will be very easy. You don't need to worry if you feel like you're not good with coding or anything, because we're going to use apps and auto-generate the codes. And then I'm going to do another demo for CNN, which is our final goal today. And I'm going to let you practice your CNN using another Matlab app that allows you to do so. So what is Matlab? To best define this, we go to Mathworks direct definition. So Matlab is a programming platform designed specifically for engineers and scientists. And Matlab is a matrix-based language, so it's very good compared to, say, any other programming language in terms of computational mathematics. You can use Matlab to analyze your data, develop algorithm, create models, or for today, we're going to use it to implement our neural network. So Matlab is a paid software. So essentially you need a license, you need to pay a yearly licensing fee, but fortunately for NTU students, you can use Matlab for free. And a lot of companies also have Matlab for available from their own licensing. Essentially, what makes Matlab different from other languages to me is that Matlab has a developer that constantly need to update their systems, right? So Matlab is not an open source language. It's you must pay for to use Matlab. So essentially, all these developer will continue to continuously develop apps and GUI interfaces that allow for the Matlab to be easily used for engineers and research scientists, or anyone, in fact, who wants to use Matlab. So the idea of Matlab is to make commonly encountered tasks such as, say, we commonly enter system identification, we commonly encounter how to build your neural network, and Matlab does this. So create apps and GUI that essentially helps you deal with this. Rather than quickly describing to you Matlab, maybe it will be far easier for me to directly show you. So I'll stop sharing my slides for a bit and I'll share with you Matlab. Share screen. Can you see my Matlab workspace?
Yes, I can see the desktop. I mean the standard main page of the Matlab.
Okay, perfect. So we are today going to start with a simple introduction about Matlab. So essentially, to the left of my screen here, it's called the current folder or the path. So Matlab behaves similar to Ubuntu or Python. So you need to have a folder open in order to access codes or workspaces, which I will explain shortly, and or ZSVs. Essentially, when I have this window open, I can call in the CSV files or the codes directly. Uh, Another thing you can do with this command window is, if you see here, all my folders are whited out. So this means that all these whited out folders, except for Matlab, is not in my path. Path is essentially, I have sort of a search machine here or folder privilege here. So when a folder is in my path, I can access files directly from it. And when you have two files in different folders in your search path with the same name on it, all you have to do is, so when you say open, say I have two CIFAR codes with the exact same name. And when I run this CIFAR code from here, I don't need to specify the location, which is sort of like this, c./users and so on. I don't need to specify. I can just type CIFAR code here and it will run the script, but it will run the script that you encounter first in your search part. So this part is going downwards. So all files that are here will run first. Then all files at the top of the list will run first. And then if there's other files, it won't run. So that's essentially what path is. But for today, I will later on give you a link to a Google Drive that contains the folder. All you have to do is from this menu here, open the folder to use all the scripts or all the data sets that I've provided here. So the next thing here is the command window. This is essentially where you input all your commands, all running your scripts. You type it here. So for example, for now, I'll try typing x equals to 1. What this will do is create a variable called x inside the workspace. And if I type it like so, it will print. But if I don't want this to print, in my command window, I add a semicolon in front of my command. So as you can see here in the workspace, the value changes to 2, but it wasn't printed similar to this. So that's the first basic of Matlab. The next basic I'm going to teach you is how to create an array or matrix. As mentioned before, Matlab is a matrix space or okay, give me 1 second to add someone. Udah. Okay, sorry about that. Where was I? So to create an array, you simply need to create a square bracket. Square brackets defines an array or a matrix. So if I type it like this, you will see that we have a 1 times 3 array here. 1 times 3 array here. No, sorry. So I will have, can you see my, by the way, can you see my variables window?
Yes.
Yes, so this is similar to Excel. You can directly access here. You can add variables. So Matlab is very convenient. Next, I want to show you how you create a matrix. This is very similar. So if, as you see before, space declares moving a column. So if I press space here, so 1 space 2 means 1 is in the first column, 2 is in the second column. To access rows, you use semicolon inside of the square bracket. So if I do this will essentially create 1, 2, 3, 4, 5, 6, similar to his. And a very interesting part with Matlab is that you can edit your variables directly, which is not available in, say, other programming language. And you can even create a new numeric array. Say this will create x1. And as you can see here, x1 is a column vector with 1 and 4. So this feature is very convenient in Matlab. And it's why today's workshop's going to be very, very easy for you. So last but not least, I haven't talked about workspace yet. So essentially, workspace is where all your variables, all your networks, all your classes will be stored. And you can save this workspace. So you can save your workspace. And this allows you to access your previously programmed variables without, say, running the program once more. And one more thing you can do with Matlab is create a new script. This new script allows you to save your command. Say I can do the same thing here with, I can create a command that does the exact same thing. And I'll need to save my script before running. Say I name this script A and run this. Now, you can't see the results because they're exact same, but I'll clear my workspace first and then run. So you have two options of saving in Matlab. One is saving the workspace, the other is saving the scripts. So I guess we stop there for a bit in Matlab. Let's see, check here. Sorry. Okay, I'll stop my screen sharing. Then I'll share back my slides. Can you see my slides now? So I explained to you a bit about Matlab just now. Sorry, I'll just full screen this. So I essentially explained to you a bit about Matlab just now. So now I want to explain what is neural networks. Neural networks is a method of machine learning that mimics the neurons in a biological brains. But since computing or simulating an actual brain in a computer is very, very difficult, we tend to replace this with numbers called, which are weights and biases. So I will not go through the direct mathematics implications of this or the. I will just show you one slide from our introduction to neural network workshop, which will explain how the neural networks work. So in general, you can see here we have a multi-layer neural network. The first layer is an input layer, and this specific input layer is for an RGB. So I mentioned before that neural network is made using weights and biases, right? So essentially what happens in this neural network is you have first your input layers, which are your data, anything. And in this case, it would be the R value or the G value or the B value. So it would be an array containing all the points in pixel points in this. And then you would multiply that particular value with all the weights. And in Matlab's cases, you have weights and biases. So you multiply by the weights and add your biases, and you get your output. And then you check if this output is similar to your target, which is the data you want your neural network to be able to calculate. And then from that, you calculate the error and backpropagate, create your new weights, and then you input it again, train it over and over until you get a function that resembles the connection between the two inputs and outputs. So essentially, that is what neural network. For more details on backpropagation and or how we calculate the training and all of that, I can link you to I will provide this PowerPoint later on with all the links to our previous neural network workshops. And so I will not go too much about the math, so I'll directly jump into how Matlab implements a neural network. So basically, Matlab provides you add-ons and apps basically to allow you to design your neural network. So these are the toolboxes that can help you work with AI, data science, and statistics. So for today, since we're using neural network, we'll be using the deep learning toolbox, which I've installed for it. I've asked you to install in the poster or in the email I sent to promote this particular workshop. If you don't have the apps installed, it's okay. You can just follow along with me as I will demonstrate and allow you to try everything. So 7 apps are the contents of the deep learning toolbox. So deep learning toolbox contain blocks of functions and all useful sort of stuff, but the big points of the toolbox are the apps. So to the left here, you have 3 apps that you can use. But today we'll only be using Deep Network Designer and these 4 apps. So Deep Network Designer allows you to build your neural network with a GUI. So if you're familiar with Python, you normally type in your layers, but this is much more convenient since you get a GUI to code your apps. I will later show you this feature. And the 4 other apps here is essentially a beginner app that allows you to use shallow neural network, which I will explain one by one to you all. So the shallow neural network essentially solves a commonly encountered problem, and they're very, very easy to use. So I'll explain to you what these 4 apps are one by one, and then I'll demo it to you. So the first app is called the fitting app. So essentially this solves mapping problems between input variables and output. So essentially this is a regression problem, and you access that by typing command nf tool. And today we'll be using the example dataset of body fat. So I'll show you later on the dataset, but I'll move on to the second app. Pattern recognition is to solve a classification problem. We'll be later using breast cancer dataset, and then we have clustering apps to cluster. So clustering is the most different here. So essentially what clustering does is you create a map and sort of group your variables into clusters. So how that works is a bit different from our previous one. So the map I explained you just now about neural network and how it works. Essentially, it's supervised learning. But now we are seeing what you're seeing right now is unsupervised learning. So this is an example of clustering using self-organizing map. So essentially, you start with the weights similar as a grid, and then you slowly input your data, and the weights will tend to move slowly, closer to your data and increase in size. So later, this will allow your network to find clusters in your data. We will be visiting the app shortly, so it's okay for now. And we'll be going to our last app first. So this is called the time series app, and it's used to solve time series regression problem, which means that the input is can be previous outputs or previous inputs. So this is very similar to regression with delay as an input. And I'm gonna stop sharing you my slides for a bit now, and I'll go back to Matlab. Screen share. So we have Matlab again. Can you see my screen? Okay. Oops. Give me 1 second. So this is we're back at our screen. So I mentioned all those NTS tool, NF tool, but really all you need to know is one command and then start, which opens a wizard that allows you to open all the apps I mentioned just now. So you start with the first app, which is fitting app. So all you need to do for today is load example dataset. And today we're using body fat dataset. So body fat dataset contains these values, age, years, weight, yeah, all these values. And I'm gonna import. Import is similar to adding, in this case, the example will be added to your workspace. Now, so you have your inputs and targets, right? And one thing to note here is there's two options here. So matrix columns and matrix rows. Matrix columns or matrix columns here refers to how your different samples are shown in different columns. So column 1 is a sample and column 2 is a sample and so on. So
sorry, we can't see the variables. I can only see the workspace and the main command prompt, command window.
Can you see the neural fitting tool? Sorry, can you see the neural fitting tool? Oh wait, oh say I stopped sharing for a bit and share the whole desktop for you to see. Share screen one. Okay. Okay. So you see here I have opened the wizard and then I click fitting app to open this window. You start with this, and then for today we're gonna we're gonna just pick the body fat inputs and body fat targets, which are example provided by Matlab, and we'll use essentially what this is data set containing your age, weight, height, and so on. And what you want to predict here is the body fat percentage, if I'm not mistaken. And there's two forms of data. The first is matrix column, where you have your samples divided in columns. So this is one sample and this is another. And what you want to do for this case is matrix columns. So matrix rows is a bit different. So you have your samples the other way around. Samples are indicated by rows. So I'll give you a short glimpse of what you should, what data in matrix row looks like. All I did was transpose that data back then, and now you have your samples in rows. So the command to transpose is just to pick the give a to your give this behind your variables. And one more thing I forgot to mention before is that you can find variables here or functions here. But if say I create, essentially what I do here is do a transpose function. So if I type a function here and I do not assign the output to a variable, the output will be assigned to variable called ans. This is a temporary variable, but this is just to let you know that Matlab can do that. Please be aware that if I type anything else, ans will be replaced. So yes, that's one thing. And then all we have to do here from this NF tool is press next, pick the validation and testing numbers, pick the number of hidden neurons. We can only work with 2 feed-forward shallow network, which is as shown here. So 1 hidden layer, 1 output layer, 1 input layer. So that's about all. And press next here. And there's 3 settings here that you can pick. The first one is Liebenbach-Marquardt. Essentially, Liebenbach-Marquardt and scale conjugate gradient is training by checking with validation. So if in general, the validation stops improving, Matlab sets the number to 6. So when validation stops improving 6 times, the training will stop. And the last one is Bayesian regulation. This Bayesian regulation will train until your gradient or your or the parameters of your training drops down to a very low number. And this is particularly very good with noisy data, but it will take you longer for take longer time for it to train. So I'm just going to show you Liebenbach and Bayesian regulation. So as you can see here, you have 6 validations, and I'm gonna plot this. This is quite bad, but we can retrain again, of course. But in general, you see here that the validation stops improving, the error stops improving, so the training stops. We can retrain again if we're not happy with our values. But again, the performance will, yeah, this is better, but still, you see that this tree is not converging. So you use another method, which is Bayesian regulation, and just press retrain again. And you see this trains until the MU or one of the training parameters drops down to a very low value. It could be your gradient, it could be your MU. Yeah, so essentially, we don't have validation checks in Bayesian regulation, and we train until the data is very, very good. So this is your most powerful training algorithm. And you also can print your performance here. This is how your accuracy improves with training. So essentially, if you see this case that the mean error is not converging, then you have you either need to use a deeper network or more training data sets. But for our app today, this is only for shallow network. So you have, say, if you have data sets that you want to easily analyze with neural network, this is your best option. And the next one is your training state, which is how your training parameters or the gradient. Gradient is essentially like how many jumps your data, how your weight changes along training. So here we may receive big error around here, and that causes the training to the gradient to increase to overcome the bigger error. And if your gradient is very small, essentially your training is have good accuracy and it's improving slowly. So when accuracy stops improving, you slowly reduce the gradient. And that's why we have converging, we train it until it sort of converges, these two converges. This is the sign that your neural network does a great job at training. So what you can plot here is your regression. So regression essentially shows how well the correlation between these two data are. In our case, all the validation and test shows about 0.9 or 0.95. So the closer you get your correlation to 1, the better. The lowest possible value is 0 and the highest possible is 1. So 0 means bad, 1 means very good, essentially. And from here, you can either test or train again or adjust your network size or import a larger data set. And again, you can generate your functions here. So for example, I generate this function. This function is essentially is your neural network. So all I need to do is save this. And if I say I use this neural network function, and oops, I cannot run. This is a function. This is not a normal script. This is a function. So the way you run it is by placing an input. So say I use the first input of body fat input. I'll get results. Why? So this is how you do it. I forgot to mention, but this is how you index a variable in Matlab. So you use normal brackets to index your variable. So you have a matrix, right? You separate the dimensions by comma. In this case, we have 2 dimensions. So essentially, we start with you can select your rows directly, or the right-hand side will be columns, the left-hand side will be rows. So you select your columns and rows directly, or you can use a colon, which notates that this means all, everything. And if you input 2 to n, this means that you want the numbers to be from 2 to n. So basically, colon is used to index multiple, pop out multiple rows. So if I do this, it will get column 2 and 3 and all the rows. So you have 2, 3, 5, 6 as your answer matrix. And yeah, we'll be moving back to function. So essentially, this prints your function. You don't need to understand everything here. Matlab is very user friendly, as you can directly use this from a user perspective. And another thing you can do is print your neural network diagram. This is just a short visualization of your neural network. This is same with the ones I posted in the slides. And another thing is we can deploy the functions directly to Simulink. Simulink is another Matlab add-on that allows you to work with block diagrams for signal processing or control management, and it even have like compilers that work with Arduino or Raspberry Pi or many famous other hardware resources. So that's where really Matlab comes to shine. We click next, and this is the final window. You see here we can generate a simple script, which is essentially how the neural network is created. So first you input X as your inputs, T as your targets, then you create a variable that mentions the train function, and then create the hidden layer size. Then you use the function fitNet, and the inputs of that particular function is hidden layer size and train function. So you can type train BR, train LM, or train SCG, and that's how you create your network. Then you specify your train, validation, and test ratio, and then train your network using train function, and you calculate your error or other stuff here. And this is all auto-generated by Matlab, so I don't need to code anything. And now I can already use neural network, which is very nice, right? If I want to plot something, all I need to do is uncomment, and that's about how you use the neural network. And yeah, have 5 those. Yeah, you can also save your network error results and all the sorts output. And how you use your neural network is simply by inputting your typing your inputs inside nets. So net is essentially a class function. So if I press this, I get my output. So this is the output I predicted using my neural network. So all in all, this is very handy. All the other apps are very similar, but I will also still show you all the apps. So the second app is the pattern recognition. Essentially, this solves a classification problem. And for this one, I will use this cancer dataset, which predicts from these features if the cancer cell is benign or malignant. So the data is again in the form of matrix columns. I'll show you again. And then I'll just open here, press next, again. This is all the settings similar to last time, and press train. And I get my confusion matrix. So essentially, this is rows specify your output and columns specify your target. Output is your predicted value and target is your actual value. So this means you have 323 outputs that you guess correctly, number one outputs, and 162 outputs that you guess correctly from number two targets. So, and these are your errors. This is the training matrix. So this is essentially how you read the confusion matrix. And you can also plot ROC, which is the true positive rate compared to the false positive rate. What you need to know about this graph is the closer you are to these two edges, the better your data, the better your network performance is. Then you can do the same things with your network and or generate your function or even create your script. And this will essentially do the same thing. I'll show you. This will run the same thing, the exact same thing with your what I just did just now. And you get your new network here, which does the classification for you. So if I type, say, net answer inputs 1, all rows. Sorry, that's the other way around. I will get my output. So the output of a classification neural network is the probability, and probability of class 1 is 0.956, which is very high, and for the other probability is 0.014. So essentially, this means that most likely this cell is belongs to class 1. So moving on to the next app, we have clustering app. So clustering, as I explained before, you have a data grid and you train your weights to get closer to inputs and you get your clusters. So I'll import the iris flowers data sets here. And all I need to do is click next and train. And you get your neighborhood distances, which specify the distances. The darker means longer distances between this input. So you see there's a bit of a separation here. So essentially this is a grid, right? Each hexagon represents the weights, and you have inputs that are closer to this cluster. Now the visualization of clustering is a bit difficult because as you see in your iris inputs, you have 4 inputs, you have 4 types of features, and imagining 4-dimensional is quite hard. So if you click sample hits here, you can see how the weights are clustered around. So you have one cluster here, another here, another here, another here. And essentially, as you see before, we have a separation around here. This means that, yeah, there's a big separation between the area here and here. And another thing you can show is your weight planes. They specify how each features are normally grouped. So if you have 2 dark weights here similar to each other, so weight 3 and weight 4 is similar to each other, this means that these 2 features are quite correlated. And then we can see the weight positions here. So we only show the weights for the two of the first inputs, two features. We have 4 features, but it's impossible to show 4 features. You will need a 4D window. So this is the best we can get. So all this is similar, automatic. You can generate. You can type your script. Again, you just need to. You don't need to go through here a lot. You can just follow here. So self-org map is the function you use. And then, so here, this is an array, essentially. The input to self-org map is an array of 2. So yeah, and then we train, and then we can view the net and plot this. So this is very convenient to use. So I'll just move on to the next app, which is our final app. I'll close everything first. This is time series app. You have 3 here, 3 functions here. Essentially, the first one is you create put inputs and pass inputs, and then get your feedback from the outputs generated, and then from there calculate the your predicted value. So you have 3 apps. This one predicts only based on the previous outputs, and this one predicts only on previous inputs. Yeah, so for today, we're going to use this. This is the most accurate in dealing with time series. So for this, I'll use pollution mortality dataset. And interestingly, this time step allows you to get your data in cell columns. So cell columns, if you see here, is how the data is configured. So you have this, all of these are the features, and each cell is time step. When you use cell column, how you index cell column is normally with the squiggly brackets or this. So pollution, if I do this, I will get the data from the first cell. So this is how you index a cell typically. And then explain quite well there. I'll just hit next for everything. It's the same. Here you can add a new feature, which is the number of delays. Press next and train, and you'll get your response. It's very good. So, or rather, maybe I retrain again, see if I can get better response with Bayesian regulation. I'm getting very, very good data response here. So you see the error is the orange lines. So all the legends are explained here, or error are the orange line, and we're getting very good data. So I'll just press here, and I can generate my Matlab function similar as 10 and create a simple script. You specify your delay years, your hidden layer, and then this NARXnet accepts the function here. Again, you don't need to know this to be able to use the neural network. You can just use the app. There's nothing wrong with it. And yeah, so that's how you use all 4 apps. So now I'm going to stop sharing for a bit. And I'm going to go back to my slides. Okay. So I'm going to send you all the link. So we'll be doing a hands-on session, which allows you to test out these apps by yourself. Is Chapman open? Where is it? Give me 1 second. Oh, where's my chat? So I'm going to stop sharing a bit. So I will share with you a link here, and then I will share with you another link. I will share with you another link. So the first link will be the dataset that we are going to use today. You can just open it, and it will have share screen. I'll go back to my Matlab. So essentially what the drive contains is this, and the other one, the Kaggle link will have the CIFAR10 dataset. So that CIFAR10 dataset will contain the CIFAR data, CIFAR10 data. So I'll explain to you what CIFAR10 data is. But for now, if you want to try out by yourself later on when I explain to you CNN. You can just download the dataset now because it's about 100 megabytes. So later we can just download now, and later on we don't need to download. Oh, and I recommend you to download everything now. There's quite a lot here, maybe about 200 megabytes of data because there's CNN data here, CIFAR10 data in our workspace too. So yeah, download it. But for our first hands-on session here, we'll start with two data sets, which I'll let you play around with. So when you typically load a CSV, all you need to do is drag it to your workspace, and it will open the menu. So you can import this as a matrix or as a table. Table is a different form than matrix, so I'll show you table first. So table is similar to your Excel form. You can add strings, you can add cells, you can, I think you add cells, sorry. You can add strings or anything, but you cannot work this with mathematical formulas. You'll need to convert this into your matrix. And how you typically do that is by selecting all of this and create a new numeric array. So what I did just now is select all the inputs and create to a different numeric array. And then what you can do is the same thing to get the output. And so I'll explain a bit about the dataset. So essentially, these are the features that you want to predict, use to predict the median house value. So I'll let you experiment with this dataset by yourself to get the feel of Matlab and try the app. So the command you use will be nnstart, and you'll get the app. So first, you will need to create your matrix here, either using the GUI or using commands if you're familiar with it. I'll let you start first now, but if you want comments, just I'll explain comments along the way, but you should try along with the table. Okay. I'm going to explain to you while you try out with the GUI. So how you normally clear is to clear your workspace, and CLC is to clear your command window, so you can clutter everything. And what you want to do to load your CSV file is use the read table command. This is using commands. You can type your commands in the script if you want to save it, and you copy the name. Oops. Put it in quotation marks and you run command. So you get a table here, which does not open for some reason. You get a table here that you can use just as now. And the way you convert a table is using table to array. This is another function. And so again, you start with a comma, and you want to select columns 1 to 8 with all the rows in it. So what you do is like this. And you get your array. So I'll let you try out all of this first, and you can message me. Feel free to message me if you have any difficulties with using the app, or you want to try out comments, then feel free to message me and ask about the comments. So I'll stop my screen sharing for a bit now. We'll be continuing our workshop where I'll be showing the solutions for those two data sets in about 10 minutes. Okay, guys, how is your progress? Anyone still want to try something out before I start with the next part? Okay, then if I think everyone should be done by now, so I'll share my screen back to my Matlab desktop, and I'll continue with the two solutions. So essentially, the first data set, all I need to do is import as numeric matrix. My mouse. Import as numeric matrix, so I get this matrix, and I can even cut this like I did with Excel, and delete column. Then I can just create a new variable, and paste. So it's quite easy, like working with Excel. And then I use NN start. Now the case with this particular data set, this is a fitting or regression problem, and my data is in matrix rows. So all I need to do is press next, next, and train with the best here, train, and see how long it takes. And we cannot plot fit because this is plot fit only works with one one feature, so x versus y. So we can plot its plot error histogram or plot our performance. So we have quite a network with a good error, as you can see with this regression value. So yeah, so practically we can predict the housing prices, and say we test with the training data set. Can do the same thing, import again. Oh wait, this is a table. I'll import again as numeric matrix. And I'll cut and delete. Then I create a new variable. Then I paste. So I can then test my tools with the train, and I'll test. See, oh, we're getting quite a nice R value here, and our mean square error is in the quite okay. And all I need to do is print the simple script if I ever want to run again and not mess with my settings again. And the second data set is airline passengers. So essentially, this row, this column denotes the month, and this column denotes the passengers. I only need the second row because if you're dealing with time series neural network and all your time steps are equal, or everything here is 1 month, it doesn't matter if you use your time step as an input. So all you need is this value, and I can delete this row, and I input and I select here and create this as an array. And then start to get my UI back, and I use the time series app here with the non-linear autoregressive, and I just put in the data matrix row, and from there I can train and plot my response. So quite good here. So very easy to work with Matlab and neural network. So, but this is all just so this is all just shallow neural network. You might want to use a deeper neural network for cases where you have images as your input or LSTM even, but for today, we're going to practice only with images. Can Excel be used to directly? I think you can. Wait, let me check. Again, you can directly use Excel, or you can still do the same thing by creating a saving your Excel file as CSV. But let's see. As you see here, I'll share my screen in a bit. I'll get my desktop. You can do the exact same thing. Yeah, you can do the exact same thing with Excel. So that's quite handy. And we'll go back now to our slides. Oh, someone chat. Yeah, exactly. Excel can be imported using the same read table or the same method. You just drag and drop. I'll share back my PowerPoint slides. Back with the PowerPoint slides. So essentially, we move on to our second demo, which is CNN. CNN is short for convolutional neural network. And what you can do with convolutional neural network, you can create here segmentation, like block out data pixels that contain an object. And then you can do object detection, classification, or localization. You can do image segmentation such as this. You can even find your post. A good example, I think this is postnet.py, or another example, I don't know. This is post estimation. So basically from your image, you train a lot of data with poses as their input, and you essentially create a model that predicts your pose based on your picture or video. And this is another interesting example, which will, I think, be we will have a workshop on. This is generative adversarial network. I'm not sure when exactly. You can just wait for the workshop to pop up in your email. Generative adversarial network generally is you train your network, certain network, to generate a picture. You train with a lot of pictures, so you put in a lot of similar style pictures, and you create a network that generates this picture. And then this picture, all the pictures generated by the network will be fed back into a classifier, and the classifier will try to classify the data if this is classify the image if this is a real image or a generated image. And these two networks will sort of compete with each other, and we call it GAN, or generative adversarial network. So this image here is not a real image. This is made by the computer, trained from this image. And you have other implementations of the CNN. And for today, we're only going to discuss the standard classification CNN. We're using the CIFAR-10 datasets. I'm not going to explain too much about CNN and how it works. I'm just going to explain the core concepts. So first of all, the first concept is called convolution. So essentially, convolution is multiplication of elements. So you see here, you have a picture which is denoted by the blue color, and the picture are denoted with pixels as data points. This pixel shows the brightness of the color red. This particular pixel map shows the brightness of the color green, and so on. So then you multiply each elements with a certain filter, and you get an output. So if you see here, the outsides are denoted by zeros. If you don't denote this at zeros, you will essentially lose one row and one column, or 2 rows and 2 columns, which are the edges. If you use a 3 times 3 filter, if you use a 5 times 5, then you lose 2 rows and 2 columns, which might contain valuable data in the edges. So what you did is pad the picture with zeros outside, and this is called padding. So in this case, you use a 3 times 3 filter and pad with a one rows and 2 columns and 2 rows, one each on each edge. So the padding will be then denoted by 1, 1, 1, 1. And another concept you will need to know is pooling. So essentially you have a large image. Say you have the previous data. The image is quite large. Not all of those data are interesting or important. You want the most important data only, which is here shown by 6. Say maybe this picture is already normalized. So you have negative values here. Normally your pictures will be in unsigned integers. So you have 0 to 255, and that denotes the brightness of a certain color. We call the different colors RGB as channels. So if you have 1 channel, it will be grayscale. If you have 3 channels, it can be RGB. So you select only the best output from here, and from here you do the same thing. And how many boxes you move here? Say you have a 2 times 2 here. How many? Say we start with -7. I move directly 2. So I take these 4 inputs as 1, and these 4 inputs as 1. This is called stride. So stride, we have a stride 2 here, which means that we move 2 each step. So we move 2 here, move 2 here, and move 2 here. So in the end, we get a 4 times 4 output, which is a way to downsample your data. If you're talking about an image, say with big resolution, 1920 times 1080, which is the standard resolution of a lot of laptops. If you train with that data, sure, you will get all the detailed information you need, but not all the informations are useful. And if say I take a 1920 times 1080 picture of a dog, and then I resize it as small as possible, like this, I can still tell this is a dog. And I don't need a huge resolution picture to be able to determine that this is a dog. So that's why we do pooling or downsampling. We downsample just now, but then why we still padding if we want to downsample anyway? That's because although you want to downsample, you don't want to downsample randomly. So the edge information sometimes might be important. So you'll need to selectively downsample by using pooling, and this will automatically pick only the best data. So I'll be demoing a bit of CIFAR10. So I'll be running a certain script which I've given you the link to. And for the hands-on session, you'll be required to download the CIFAR10 datasets, which I send the link through Kaggle. So the normal CIFAR10 datasets you get in 5 batches and 1 test batch. So 5 training batch and 1 test batch. Each batch contains, I think, 10,000 data, 1,000 for each label, each category. So 1,000 airplane pictures times 5, so 5,000 airplane pictures in total automobile. And this is a very common example that you can use to practice your CNN. And the size of the CIFAR data is 32 times 32 pixels for each picture, and they have 3 channels, so RGB. And for our hands-on session, we'll be using this deep network designer. But first, before going to the deep network designer, I explain to you the workflow of a CNN code in Matlab. So I'll stop sharing my slides here and then move back to Matlab. And share screen. And we go back to Matlab. So if you can see my screen here, I'll open my CIFAR code. I'll clean up a bit first. So Normally, you will need to download your CIFAR code from the standard source, which is this URL. But I've commented this out because I've downloaded it for you in the CIFAR workspace.mat. So CIFAR wspace.mat. How you normally download it with code is you create a temp directory, create a URL, and use the helper CIFAR 10 data, which I've also included, but we're not going to use since it will be quite tedious for you to download directly the CIFAR data. And the helper CIFAR 10 data has a function that allows you to download and load. So as I've mentioned before, your data comes out as 5 batches, and each batches is 10,000 image. So, 5,000 yeah, 1,000 for each. Okay. 10,000 image. And what Matlab does here is quite bad actually. They just mix every data together. So yeah, that's what Matlab done with the, and this is available from Matlab example, the helper CIFAR 10 code. And for today's purposes, it's okay since we're going to be training the whole batch all together. So we're not going to separate the training into batches or something. So what I will do first is I load my CIFAR workspace. The command load will be very useful for you to load your data. And this command essentially load CIFAR workspace.mat, and these are the variables that I will load. So I'll only load these 4 variables. And then I'll try to find the size of my images. So I'll run this for a bit and pause. I'll just run this for a while, then let everything go. And while I explain. So these are the height, width, number channels. I want height, width, and number channels to be inputted as my variable, but I don't want to specify manually. So I take from the size of training image. The CIFAR 10 training image are made in the form of, where is it? 4DU in 8. So this means that our data has 4 dimensions. The first 2 dimensions are the width and the column of the height and the width of the picture. The third dimension is the number of channels, and the fourth dimension is the number of samples. So we have, we want the height, width, and number channels for our filters, for our layers in neural network, and we don't want the number of samples. So we use tilde here. This will output nothing. This will automatically terminate the data you get here. And then from there, you get image size as the height, width, number channels. So you have 3 channels, 32 and 32, which is specified here. If you check 32, 3. 32 is number of filter, height is 32, and image size is 32, 32, 3. So you have 10 as the numbers of categories, and categories will be the training levels. You have for this particular exercise, we'll be using a 5x5 filter. So we have a 32 number of filters, which is the number of, I showed you the graph just of neural network, right? So essentially, what 32 filters means, we start from 3 channels, right? We want 32 filters. So we initialize 32 random filters, and we get from the 3 channels 32 random like filter outputs. So we want to be able to extract 32 different features from the 3 channels, and the 32 features can take from any of the channels. So it's a combination of all. So we don't have to do the math for this, because this is what essentially machine learning does. They do the math for us. And then we create the image input layer, and then we create the middle layer. The middle layer contains the convolutions and filters. So the first year we use convolution with 5x5 and 32 filters, and we use 2 padding as to not lose the edge data. Then we use a important activation layer, which we will learn about if you watch the intro to neural network workshop. And then you will use the pooling layer to downsample into 15x15. So we use a 3x3 filter, and then from the 9 data, we pick one of the best. Then we move 2 steps, and then we select another one. You can calculate it and you will get 15 times 15 layer. This will be explained more in our intro to CNN workshop, which we have already uploaded in YouTube last semester. I'll leave the link in the slides later on, and I'll send you all the slides after this workshop. And after that, we'll repeat the layers 3 times, and we'll be done with 3 times 3 times 64 data. So the last number of filters, we want to extract 64 filters. So we have a fully connected layer with 64 input, and we add another ReLU layer. This is an important activation function, and we collect the fully connected layer, number image categories. And we then use the softmax layer, which is a layer that calculates the loss, and then we output using the classification layer. This is our final layer. Then we combine all these 3 layers into this layers variable. In total, we have 15 layers. And then we initialize the weights with random numbers. And we pick out our training options. Again, this will all be explained in our either Intro CNN workshop or Intro to Neural Network workshop. I think this will be better explained into your Intro to NN workshop. And for this particular code that I given you, I set toTraining equals to false. And if toTraining is false, it will not run this line, which normally would train your network, but it will load my pre-trained networks because training our CNN would take about an hour. Depending on your PC, it could be faster, it could be slower. Yeah. So, and then all you need to do is ytest equals to classify cfa10.net. This is the command to classify using your CNN. And cfa10.net is where you train your function just now. And you get your accuracy by summing all the correct labels divided by the total labels. So that's about it. That's the CNN in Matlab. But for now, we're not going to use this code. This is just for you to see. We're going to open the Deep Network Designer. You do that by typing Deep Network Designer, capital N and capital D. Or you can go to your apps here, which also contains your other neural network apps. So I'm gonna let this run for a bit. It's quite Matlab is quite heavy, by the way. So yeah, if you have a not so good PC, this will take quite a while. But yeah, be patient. It's okay. It's not so heavy on your GPU or on your CPU. It's more heavy, if I'm not mistaken, on your RAM. That's from my experience. And you want to create a blank network, and you start with an input layer, and your size will be 32 times 32 times 3. And then you want normal zero center and normalization. Then after your first layer, you want to input your convolution layer. Your filter size will be 5 times 5. Dilation and stride will be all 1. Number of filters will be 2. And you want a 2, 2, 2, 2 padding. And then you add your ReLU layer. And you add your pooling layer, max pooling to the layer. And the pool size will be using, which is 3 with 2 strides. With stride. And we won't be padding here. So yeah, I'll let you do this on your own. So you can try, look at the examples. And I'm going, next up, you'll be loading your data. So I won't be doing this completely. I'll let you try it out on your own, because if I show you, then I'll just be handing you an answer sheet, and that would be bad practice. So how you select your data is you simply import your image and select train here, because this is your training image, right? Now the inputs of this folder will be your a folder that contains the all the outputs in subfolders. So if I cancel this first, I can show you what that looks like. So this looks like this. So we have a lot of image here, 10,000 or 5,000 for each label here. And we're going to do the same thing with the Sifatan test. Oh. And we'll not set locations here. Oh, sorry, got that. We'll not set anything here. This is for rotation. So if you want your network to be able to predict reflections or scalings or rotation, you need to set this out to help you train your network. And you import your data. And you can see here, you can even display the classes easily. These are examples of frog. So this compared to the batch testing you can download from previous data, or rather a lot of databases, is very convenient. So a lot of times when you're doing your own research, for example, you'll get your data will be in this form. So you will have subfolders containing all the images, and all you need to do is input using the GUI. This is very simple compared to other training language, other programming language. And you can set your training options. You can follow the ones I typed here. And another important option is that you can pick which device you want to execute. If you have parallel computing toolbox, I think you can train with your GPU, or you can train with your CPU. But for other cases, I think you can only train with your CPU. So let me just train here. Oops, I cannot work with the train. I did not create. Okay, so I'll let you train on your own. Then I will train I will do the training as well. And yeah, I'll be discussing the results with you in a moment. So I'll maybe give you about 10 to 15 minutes to try this out. I'll be here and you can chat to me directly if you have any issues or any errors. So, okay. Feel free to practice using the app. Okay. I'm pretty sure most of you are not going to finish training. You'll need either a supercomputer or some GPU server, or use cloud computing if you want to be able to train your network on time. But it's okay. I don't even finish my training, but I'll share with you my screen. I'll share with you my screen, and as you can see here, I managed to get half of my training done, but I'm going to stop it anyway. And I get my accuracy about 73% here, but I'm not going to use this one. I'm going to export train network. Oh yeah, you can generate code, Matlab code similar to this, but we're not going to discuss because we already discussed the previous code one. And yeah, the network I generated was the train network 2. And as you can see here, I can test the network accuracy using this particular line. Oh, I hear it. Okay, I'll try to finish. Give me 1 sec. Okay, sorry about that. Okay, so we continue on with our discussion just now. I can use this line to my accuracy of my train network. Now, wait, I need to classify first. Another handy function you can do with Matlab is you use Shift Enter to skip one line in your command line. That way you can use the command line to run multiple functions. Okay, so I will train using my train. I will run my train network _2 and see how much accuracy I get. So 73% as mentioned in the window just now. So I exported the window. For you who want to try this small feature out, you can just double click on my cfile workspace2.mat, and this will output train network 1, which is a network I've previously trained. So I guess that's about how you use your Matlab network. Oh, also one more thing. I didn't show you this feature, but if you open Deep Network Designer, you can import your network or a network you coded before with cifra10.net. Say I have my train network and I'm not content with the results of this train network. Maybe we could add more layers. Then I could just add from here, which is very convenient. I can add, I don't know, maybe I want to convolute another time, or I want to add more fully connected layers to help classify my data. We can all do, there's a lot of things we can do with the network designer. Another one thing you can do is you can download one of these pre-trained networks and do transfer learning, but this is not in my workshop's constraint for now, because the main focus is only to get to CNN, and I think for now we've gotten there. So that's how you test your accuracy, and you can even check if classify my train network tool with, say I want to see what's the, I want to input a new image for say I want to train a new image. So here I get my n is categorical and I get a cat. So I test random, and then I want to check test labels. And the first data is a cat. So that's how you use your network later on. You can use the classify function and call upon your network. Now, the one drawback with the deep network designer is that all those shallow neural network apps, you can generate your network in net, I think. Hey, let me just run one. Oops, that doesn't work. Oh, never mind. I'll just create one. Say the fitting app. So we run this. I'm just gonna go fast train here, and say I generate the network here. Oops, sorry, wrong button. I generate my network here and save the network. This network class cannot be opened using the deep network designer. If I open the deep network designer again, you won't find net here. So that's one drawback of the deep network designer app, or rather the drawback of all the shallow neural network apps. This deep network designer is a separate thing. There's also other toolboxes you can download from Matlab. How you do that is click on add-ons. I'm sure if you have installed all the prerequisite toolboxes from the email I've sent you, you've done this. So you can check here, AI, data science, and statistics. There's lots and lots of app that is available here. And some of them are official Matlabs from Matlab development, and some of them are from either staff created them or people sharing the apps. So there's also one that works with text analytics, so you can do NLP with Matlab. And I guess this workshop really can show you how Matlab is made to be easy for you to use compared to say other programming language. And I'm going to stop sharing because and go back to my slides because we've reached the end of our workshop today. So as I've promised to you, I'll send you all the slides. Wait, give me 1 second. The first link is the Google Drive link where you download your workspace, and this one is the Kaggle. And this one is a Matlab example, which is the one I got my CIFA code from. This particular example is from RCNN, if I'm not mistaken. But in the front of the code, they have a CNN, which I've used here. I've cleaned up the code, so for my CIFA code will contain only the important parts of the CNN, whereas this one has a lot of other parts that related to RCNN. And also, as I mentioned before, MLDA did a workshop in semester 1 for CNN, and you can watch it using this link. So before we end, I have 2 things that I want to do. The first one is I want to take a group picture with us. So if you want, you turn on your camera so we can take a group picture. So if you can turn on your camera, don't be shy. We can take a picture for all of us. All of us in here. So turn on your camera. So only a few of you wants to turn on your camera, but that's okay. Say cheese, guys. Okay, and that's a picture. Thank you for attending this workshop. And one more thing I have to ask your favor is I need you to all help me with this feedback form. So it would be really helping MLDA if you fill in this feedback form. And that's the last thing for me. Thanks for attending this workshop. I hope it has helped you, and I hope it has inspired you to again watch more workshops about neural network from MLDA. We have all sorts of other workshops. We have GAN workshops. We have introduction to reinforcement learning workshop. And we have previous workshops, which is available in our MLDA EEE YouTube channel. You can simply access this by Googling MLDA at EEE, or you can look at one of our social medias, which is Instagram and LinkedIn. Thank you guys, and have a nice day. Oh yeah, if you have any question, feel free to email me or you can type it now.